morning, students. Today we are going to see the topic of maxima and minima for the functions of two variables. Actually, if you are having a single variable means we are having some row, and if you are having two variables, that is if you are having x and y, we are having some working code for how to get the maximum and minimum value for the given function there. Now we can see what is the working rule here. First, initially we have to find that is fx. Fx means it is nothing but dou f by dou x. That is, we have to differentiate our function partially with respect to our x. Similarly, fy. Fy means differentiate the function partially with respect to your y. And then you have to equate both fx and fy to 0. Equating, you will be getting some values there. That is, you will be getting the value for our x and y. Okay. And what is our step 2 means? Our step 2 is nothing but we should know what is the meaning for R. R means it is nothing but rho square f by dou x square. It is nothing but the differentiate already what we have got on our fx. We have to differentiate that function once again with respect to our x. And similarly, S means it is nothing but dou square f divided by dou x dou y. That is, whatever the thing we can do, we can differentiate here. That is, we can differentiate f of x with respect to y or f of y with respect to x. Both is possible here. And similarly, t means it is nothing but what means f of yy. F of yy means we have to differentiate only f of y with respect to y once again. So basically, you should know what is the value for our R, S, and T. With the help of that only, we can go for our step 3. Step 3 means we have to evaluate R, S, T at each stationary points. That is, if you are solving our first step, we will be getting some points there, no, for our X and Y. That points are to be called as what means stationary points. All those points we have to come. That is that the coordinates, that is x and y. That x and y we have to come and substitute in our R, S, and T. So what are all the things we have to do it here means initially if you are calculating RT minus S square value is greater than 0 and R value is less than 0 means we can judge that our function is here maximum. Our function is here maximum value of f of x comma y, and if rt minus s square is greater than 0 and r value is greater than 0 means we can say that our function is here minimum value, that our function is nothing that is our function is attaining value that is our function is attaining the minimum value of f of x comma y. And if rt minus s square is less than 0 means then we can say that a given coordinate, that is the coordinate what we have derived is nothing but a saddle point there. So all these things are the working rule for our function to find out whether the given function is attaining the maximum or the minimum value for our coordinates. Now, if we are seeing some problem based on this means, we will be getting some clear idea how to define that maximum and minimum value for our given function. Now we can see a simple example here. That we are examining. Here we can see an example, that is examine f of x comma y equal to x cube plus y cube minus 12x minus 3y plus 20 for its extremum value. That is, here the function is given here. We have to differentiate with respect to your x and we have to differentiate with respect to your y. And then we have to find out our R, S, T. All these things we have to find it out, and then we have to identify whether our function, that is the coordinate what we have gained is maximum or minimum. Okay, that is initially we have to write it. That is we can start our solution by giving that your function f of x comma y is x cube plus y cube minus 12x minus 3y plus 20. Differentiate this function partially with respect to your x, that is fx. So here two terms are there with x cube minus 12x. So we can differentiate this 2 alone. So x cube if you are differentiating, you will be getting 3x square, and minus 12x if you are differentiating, you will be getting minus 12. Similarly, fy means if you are differentiating this function with respect to your y means you will be getting 3y square minus 3y means you will be getting minus 3. So if you have to differentiate partially with respect to your x and then partially with respect to your y, and then you have to differentiate this fx once again with respect to your x means only you won't be differentiating this 12. You will be differentiating this 3x square, and this 3x square is nothing but you will be getting what means 6x. Okay. Similarly, yes means fxy. Fxy means this full term. If you are differentiating fx with respect to your y means there is no y at all. So no need to differentiate anything. You will be getting only 0. Similarly, if you are differentiating fy with respect to x also, you will be getting only 0 because there is no x in here. So you will be getting the value for your s value equal to 0. Next, we can come for our t value. T value means you have to differentiate fy with respect to your y itself. So you have to differentiate 3y square minus 3 with respect to y. So here there is no y in the second part. So if you are differentiating 3y square means you will be getting the value as what means 6y. So this is the value for our RST. So you have to find the stationary point by solving fx equal to 0 and fy equal to 0. That is 3x square minus 1 equal to 0 means you will be getting x square equal to 4 or else x equal to plus or minus 2. Similarly, 3y square minus 3 equal to 0 means y square equal to 1 or else plus y equal to plus or minus 1. So if you are merging all this here, 2 points we are getting for x and 2 points we are getting for y. So you have to merge plus 2 with plus 1, plus 2 with minus 1. This is one pair. That is, this is two pair. Similarly, minus 2 with the plus 1, minus 2 with the minus 1. So totally how many coordinates we are having here means 4 coordinates we are having. So for all these 4 coordinates, we have to identify what's the value we are going to get for our RT minus S square. Based on that only, we can judge that whether the function is attaining the maximum or minimum value. So beginning, we have to take at 2 comma 1. 2 comma 1 means you have to substitute this 2 comma 1 in your R. So R means as usual it is 6x. In this 6x you substitute this 6 value below. So 6 into 2 means you will be getting 12. This value is greater than 0. Similarly, S value already is 0, so there is nothing to do. So T value 6 into Y. 6 into Y means Y value, what's the thing we are having here means 1. So 6 into 1 we will be getting the value as 6. So this is a value for your T. So now we can examine what's the value we'll be getting for RT minus S square. So RT minus S square means 12 into 6 minus 0 means 72. It is greater than 0. So already you're having R value is greater than 0 and RT minus S square is greater than 0 means according to our working principle, the coordinate, it is nothing but the minimum point. The coordinate is nothing but the minimum point and the minimum value, now it is nothing but we have to substitute this 2 comma 1 in our original value, that is in our original function. What is the thing we are having in your f of x comma y? That is a given question. There we have to substitute what's the thing we are getting here. So what's the value we'll be getting if you are substituting in the place of x equal to 2, in the place of y equal to 1 means you are getting 2. So this is the first minimum value for our given function. Similarly, we have to check for our next coordinate. Next coordinate is minus 2 comma 1. Minus 2 comma 1 means similarly you can substitute in your R, see whether it is less than or greater than 0, S value, T value, and then RT minus S square value, it is less than 0. So we can, if your RT minus S square is less than means there is nothing to say. We need not proceed the problem further. So we can declare there itself that the coordinate is nothing but the saddle point. So you have to identify whether RT minus S square is greater than 0 or less than 0. If it is greater than 0 only, we have to examine whether it is maximum or minimum. If it is less than means it is nothing but the saddle point. So next we can see what are all the other two cases we are having. So similarly, if you are having this one, that is when you are having this value as 2 comma minus 1 means can say that R is greater than 0. Similarly, in this one, RT minus S square is less than 0 means it is nothing but the saddle point. And at minus 2 comma minus 1, you will be getting RT minus S square is 72. It is greater than 0. And R value is less than 0. We can say it is nothing but the maximum. If your R is greater than 0 means it is minimum. Here if R is less than 0 means it is nothing but the maximum. So your maximum value is f of minus 2 comma 1. What's the value we are getting here means 38. So almost two values we are having. One at 2 comma 1, another one is minus 2 comma minus 1. So two values we are attaining. One is minimum value, another one is maximum value for your given function day. Thank you.